Okay, we're on to question 9. The last question on the paper, 50-mark question. You'd be expecting something like this in the stats question in there. So here it is our last one. Dara is studying to be a vet and is investigating the relationship, if any, between the weight, W, grams, and the length, L, millimeters, of newborn turtles. Dara organized a study of 10 randomly selected newborn turtles. Their weights and lengths are given in the table below. So yeah, we can see, obviously, we say just turtle 1 here. Turtle 1 has a length of 49 millimeters and a weight of 29 grams. If we go over here to turtle 1, 2, 3, 4, 5, 6, 7, so turtle 7 has a length of 50 millimeters and a weight of 30 grams. Okay, Dara calculates the correlation coefficient to be 0.44. What does this mean in the context of the data? Okay, so 0.44172159.4, that would be, people would argue on this one. Some people would say that's a weak correlation. Some people would say it's a moderate correlation. Either way, it's a positive one because it's plus. So it's either a weak positive correlation or a moderate positive correlation, and we're accepting either of those. Between the weights and lengths of the turtles, the longer the turtle is, the heavier it will be, and that's a 5-mark question.
So this one's marked on a 0-3-5 scale. So partial credit here for 3 marks is either saying weak/moderate relationship or correlation, or saying a positive relationship. So either of those, you need both parts to get the full 5 marks. But if you only wrote one of those two things, you can have partial credit there for 3 marks.
Okay. So, hopefully that was kind of a way of easing into the question. When Dara looked at it, he was surprised that there wasn't a stronger correlation between them. He examines his data. He sees that one of the weights is 338 grams. Obviously, that's far heavier than all the other ones. He realizes this is a typo, and he amends it to the correct value of 38 grams. You now had to calculate the new correlation coefficient. There are 4 different types of calculators commonly in use now, what we would call the old Sharp, the new Sharp, the old Casio, the new Casio. So there's different ways of doing it. So we won't go through the steps involved. But the answer you should get, regardless of which calculator you have, is 0.947453, and that's a 5-mark question.
So this one, it's actually a 10-mark question on.
Okay, it's a 10-mark question.
10-mark question.
It's a 10-mark question.
It is, yeah. So it's a 0-4-10 scale, and its partial credit here for 4 marks is an incorrect answer, but within the range of 0.94 and 0.955. So if you've not given that answer as accurately as you should have, so you've written 0.94 or 0.95 and you've just rounded, that is not accurate enough for a correlation coefficient. It needs to be more accurate than that. So if you've just written values like that, that would be partial credit here for 4 marks. And then full credit is for that answer. You only need to write that answer down to get your full credit there.
Okay, so yes, so you can literally just write down the answer and you get full credit. So let me just ask you, Andrea, if they were slightly off, could you just say that part again?
So if they wrote, say you had the right answer, came up on your calculator, but all you write down in your paper is 0.95, so you rounded it to 2 decimal places, that's not accurate enough. That would be partial credit in this case, because you have found a correlation coefficient between 0.94 and 0.955, which is what the criteria for partial credit is.
I have you. Perfect. Okay.
Let me I'll just say one thing on that one again. If you had rounded it to 5 decimal places, so you had it as 94745, we would count that as full credit, but anything less than 5 decimal places would not be accurate enough.
Okay, gotcha. Perfect. Okay, so we see Dara decides to draw a graph of his finding using the amended value. The graph of the following is produced here, and you're asked to draw a line of best fit. So we're expecting that most people will draw the line of best fit by eye, and just as long as it looks like roughly like this, where you have roughly speaking, as many data points above the line as below the line, and they're quite tightly packed around the line, that's going to be fine, and you're going to get, that's a 5-mark question.
Yeah, so this one's a 5-mark question, a 0, 3, 5 scale again, and you're looking for your line to be as close as possible to as many points as possible. We are taking partial credit here for an attempt at a line of best fit. Okay, so just look at your points and say to yourself, is your line sitting so there are as many points as possible near to it as it could be? If it's, everyone will draw this slightly differently. So if you can be confident that most points are as near as possible as they can, that's fine. That will get you full credit. But if you had made a mistake there, like you suddenly have a couple of points that are quite far away from that line of best fit, that would be an attempt at a line of best fit and partial credit in this case.
Okay. And we kind of know, we know some people who will use the X bar, Y bar, the average of the X's and the average of the Y's, and that should be absolutely fine in this case as well. And that might lead you on then to your next part, finding appropriate readings from this line, taking appropriate readings, find the equation of the line of best fit. So what we need is we need 2 points on that line to get your slope. Once you have your slope, and you can use one of those points, you can use y2 minus y1 is equal to m times x2 minus x1, and eventually you should get, when you've done the manipulation of that, you should get y is equal to 1.7971x minus 60.445. And of course, you could have done that on the calculator as well. And that question was worth 5 marks.
Yeah, so in this question, for our it's a 0, 3, 4, 5 scale. And for low partial credit, we're looking for any work of merit to find the slope. So if you wrote down the slope formula and put some substitution into it, that would count as work of merit to find the slope for 3 marks there. For our 4 marks there, so for high partial credit, you would be looking at a slope within the range of 1.5 to 2.1. So range between 1.5 and 2.1, and then it goes on to find the equation of the line. So you have working towards finding the equation of the line. Now, obviously, the answer we've given is for the equation that we have drawn. Your equation will be different to that because everybody will draw them differently. But if you can look at it and say that you have found the slope correctly from 2 given points on your line, and then substituted into the correct formula and worked out the equation of the line, that would be your full 5 marks. So it's not necessarily the answer you're seeing on the screen or that you're seeing in the scheme. It's the correct answer for your line.
And to a certain extent, they're going to find out on part V whether your line is correct or not. Because when it says use your line of best fit to estimate the weight of the newborn turtle of length 60 millimeters. So the X is your independent variable. We're subbing in for the independent variable, the 60. When I put that in for X, I get my answer to be 47.381 grams. And that's a 5-mark question. And Andrea, that'll kind of inform them, won't it, whether their line of best fit was correct or not.
Yeah, absolutely. So this one's marked on a 0, 3, 4, 5 scale again. So low partial credit here is identifying 60 as the input needed. Okay, so it's substituting in 60 into whatever equation you have. So it's identifying that 60 as needing to be an input into the equation of your line. And that's for 3 marks. And then for high partial credit, it's an answer in the range 40 to 55. So an answer in the range 40 to 55. Now, if your answer is between 45 and 50, that becomes full marks. Okay? So if you had an answer of 47, full marks. But if you had an answer of 44, it would be high partial credit because it's lying between 40 and 55 and it's not in the range you need for full credit.
Okay, so anything between 45 and 50 is accepted for full credit.
Absolutely, yeah.
Okay, great. Okay, great. Okay, so moving on. Actually, part VI was originally in our exam, but we took that out. It was just for finding the average. That was going to be a 5-marker, but we moved that 5-marker. Now that makes sense why the correlation coefficient became worth 10. So that part VI actually wasn't in the final exam. Okay, part B. During his research, Dara finds that the global mean weight of this type of turtle is 31 grams with a standard deviation of 2 grams. He suspects that the area from which he chose his samples has turtles which are heavier on average than the global mean weight. Test this hypothesis at the 5% level of significance. Clearly state the null hypothesis and the alternate hypothesis. Okay. Again, you might want to read this one a couple of times before you get stuck into it. The null hypothesis is a hypothesis of no change. It's an interesting one. I bet you people out there have thought about it the other way around. They're saying he suspects that the turtles from this area are heavier. So therefore, they're thinking that is his null hypothesis. But the null hypothesis is the hypothesis of no change, that the mean weight is the same as it always was. It's 31 grams. So mu equals 31. The alternate hypothesis is the mean weight is not 31 grams. Okay. And it's not that he suspects it's heavier than 31, but we don't say that. We just say that the alternate hypothesis is that it's not 31 grams. Okay. What are we going to do? First, we're going to get the test statistic, the z-score. So n is equal to 10, x bar is equal to 32.7. That's the average. Oh yeah, that's the average of a sample. So the x bar is the 32.7. So I think we're going to have needed to get that anyway to do this question. So that was what we were referring to in part VI in the last part, was to find the average. But you're going to have to find that average here yourself to use if you're going to do to get the z-score, and sigma then is equal to 2. Okay, so here we go. Z is equal to x bar minus mu all over sigma over root n. And again, sometimes people wonder, I bet you there's some people out there haven't got the root n. Okay, they've treated it like the z-score question we had earlier on in the paper, but you have the root n there because it's a sample, and again that's why it's x bar and not x, because it's a sample mean. Okay. So we fill them in 32.7 minus 31 all over 2 over root n. So the z-score is 2.69. Okay. A z-score of 2.69 is obviously greater than 1.96. We're in the critical region. So we're in the region where we reject the null hypothesis. So the result is significant. There is evidence to reject the null hypothesis and suggest that the turtles are heavier. So these turtles are heavier than the original, than the overall mu. So we reject the null hypothesis, we accept the alternate hypothesis. We could also do this using confidence intervals. It doesn't actually direct you to get the test statistic, which is the z-score, so you could do it using confidence intervals as well. I actually prefer doing it this way myself, because again, I needed to get x bar, my sample mean, so you had to figure this out. So when you fill it all in, you get 32.7 plus or minus 1.96 times the standard error of the mean, which is 2 over root 10. And when I get that, I get 31.46, less than mu, less than 33.94. What I can say is, well, the sentence my guys know that I always say is, I can say with 95% confidence that the true mean weight of the turtles, this variety of turtles, lies between 31.46 grams and 33.94 grams. 31 is outside the 95% confidence interval, so we reject the null hypothesis. These turtles are not the same as the original, and in this case, they're going to be heavier. That was a 10-mark question.
So this one's marked on a 0, 4, 7, 8, 10 scale. So low partial credit here is some attempt at creating a confidence interval or finding a z-score, but not completed. So you attempted to use either of those two methods, but you stopped, or you changed your mind and you did something else or whatever. But if there's evidence of trying to use a z-score or trying to find a confidence interval, that would be low partial credit for 4 marks. Mid partial credit would be getting a z-score, but not correctly having the 2 over root 10 on the bottom. So not correctly using the 2 over root 10 on the bottom. So that would be mid partial credit for 7. High partial credit is you have created a confidence interval or found a z-score, but you've made a mistake somewhere, okay? Or you've not finished. So either of those things. So you've stopped too early, or you have made a numerical mistake going through. So like we've had on a few questions, your high partial credit is for a nearly correct solution, but with one mistake. So note on this question, for full credit, you do need to conclude this question. So you need to say you're rejecting the null hypothesis and that the turtles in this area are heavier. Okay, so you do need to have that to get your full credit for 10 marks.
Okay, and now, of course, at this stage of the question, particularly this stage of the exam, some people might be flagging at this point. You might be finding it a bit tricky, but what we always say is just try and persevere through the question, because you're kind of back here to square one again. If you're going for the H6 in this paper, you might just need to get low partial credit in this question. You might be happy with that. Those of you going for a H1, of course, you want to get this question right. You see p-value, you know exactly what you have to do. Dara finds the global mean length of this type of turtle is 49 millimeters with a standard deviation of 3 millimeters. Again, he suspects that the area from which he chose the samples has turtles which are longer on average than the global mean length. By finding the p-value, test the hypothesis at the 5% level of significance, interpret your result in the context of the question. I just added in a little comma there, you can see. I'll just say that sentence again. By finding the p-value, test this hypothesis at the 5% level of significance. Of course, if you practice these questions, you knew exactly what it meant. There's no point in doing a confidence interval here. As I said, I prefer doing confidence intervals if I can, but in this case, there's no point because I need to get my Z score. It's a sample. The size of the sample is 10. We know that because it was 10 turtles. The sample mean, in this case, we're talking about the length is 51.83. Mu is the original weight or length, I should say. The global mean length is 49 millimeters. And standard deviation is 3. Okay. So what do we do? We say Z is equal to X bar minus mu over sigma over root n. We fill in all our values. We work out our Z score. It's 2.98. So straight away, you're right out at the edge of our bell curve. So you're saying 2.98 is greater than 1.96. You could reject the null hypothesis straight away, but of course it directs us to find the p-value. So what we're doing, with the p-value, what we're doing here is this. We're out here at 2.98. We must find this little bit of area here. We must get the equivalent one over here, minus 2.98. We must get those two areas. How we do it is we get this area here. So what we say is the probability of having a Z score greater than 2.98 standard deviations is the same as 1 minus the probability of a Z score less than 2.98. We can work that one out. That's 0.9986. We can get that from page 37. So where are we? 2.98 is our 0.9986. I'm subtracting that away from 1. That's going to get me that little bit of area down there. I think it's 0.0014. I'm multiplying it by 2 so that I get the two little bits of the tail on either side. I'm adding them together. It's 0.0028. That is less than 0.05. So we have a low p-value. As we always say, if p is low, H0 must go. In this case, what we can say is the result is significant. We reject H0. The mean length of the turtle in this area is not equal to 49 millimeters. And that's a 10-mark question.
So this one is a 0, 4, 7, 8, 10 scale again. And low partial credit is for some attempt at finding a Z score. So if you have some correct substitution into a Z score, that would count for low partial credit here for 4 marks. Mid partial credit would be getting your correct Z score. So if you got to your correct Z score and stopped, that would be mid partial credit here for 7 marks. High partial credit is you've found the Z score correctly, you've concluded correctly, but you have not found the p-value. Okay, so like Owen said, up at the 2.98 greater than 1.96, we could conclude at that point. But the question directs you to use a p-value. So if you did stop at that point and you just found your Z score correctly and correctly concluded, you would then only get high partial credit because you haven't found the p-value as told. And remembering that for full credit here, you do need a conclusion. So you do need to say that the result is significant, we're rejecting the null hypothesis, and the mean length does not equal 49.
Okay. Andrew, I think that brings us at the end of the paper. Isn't that right?
It does.
So the kids are they're flicking over to see the next page and there's nothing there. They're breathing a sigh of relief. They've got to the end of this hopefully within the 2.5 hours, and they have a little bit of time left over maybe to look back at their questions. Well, Andrea, let me just say thank you very much for talking us through that. I'd
Thank
say
you.
everyone has learned a lot from the process, and
I hope so,
just
yeah.
yeah, and thanks very much for all the effort you and your team have put into creating the free prees for the students of Ireland.
No problem at all.
Very good. On that note, guys, I'll remind you out there that the window is now open for submitting your results anonymously. So I think with nearly 750 people did it last time around for paper one. We'd be delighted again if people would do it for this paper or paper two. Okay, guys, we'll see you back at the Tuition Centre soon.